You're going to discover that the lambda 1 is not equal to lambda 2. When the light moves from air to water, we're going to discover that n1 is not equal to n2. You're going to discover that the velocity 1 is not equal to velocity 2. You're going to also discover amplitude 1 is not equal to amplitude 2. You're also going to discover frequency 1 is equal to frequency 2. By the way, frequency 1 is equal to frequency 2. Okay, so these are the things we're not going to discover. We're going to prove them. So you're going to have, I'm going to have the air and I'm going to have water, right? And then let's draw a normal line. Please do not call it a green line. This is a normal line. Why it is a normal line? Because it is perpendicular with respect to the boundary. We're going to call it boundary. Boundary of what? Boundary between two medium, the air and the water. Okay, good. Why these are two different medium? Because the air, the index of refraction is 1, the water index of refraction is 1.33. Yesterday we discovered that when the light moves from water higher density or bigger end to the smaller end, then you can get what you call the critical angle, right? If the critical angle is bigger than, if the angle is incident angle bigger than critical angle, then the light in the, even in the water reflect, right? And today we're going to do the different thing. We're going to move from actually air, right? We're going to move from air and we're going to go to the water. So air, right? So this is air, and we're going to call it incident angle, and we're going to move to the water and we're going to call it a refracted. So this is refracted. This is refracted angle, okay? So here's what we're going to discover. Let's make a list. Number one, we're going to discover that the amplitude A, by the way, 1 is equal to air and 2 is equal to water. Amplitude 1 and amplitude 2. So you're going to write amplitude 1 is not equal to amplitude 2. We're going to write lambda 1, lambda 2. We're going to write lambda 1 is not equal to lambda 2. We're going to write frequency 1, frequency 2. We're going to write frequency 1 actually equal to frequency 2. We're going to write velocity 1, velocity 2. We're going to write velocity 1 is not equal to velocity 2. We're going to write, what else we're going to write? We can keep going on. N1 is not equal to N2. N1 is not equal to N2. We're going to write that the incident angle is not equal to critical angle, right? Well, the refracted angle. Okay. So let's discover this thing. Before we discover this thing, let's remove the big misconception, and that is try to be able to read the graph of y versus t, right? Okay, what am I talking about when I talk about the talk? I'm going to give you three waves: wave 1, wave 2, and wave number 3. So this is yt, this is yt, and this is also yt. Make sure you understand this one. Y of t is equal to a sine omega t, right? And omega is 2 pi over period, and yx is equal to a sine kx, right? And k is 2 pi over lambda, right? And then if you can put it together, you have no problem. We have no problem putting them together. A sine kx minus omega t, right? Now, which one is this one? Let's identify which one is this one. I have 1 equation, 2 equation, 3 equation. This now is, of course, this one, right? Because this is the time and this is the time. Make sure you understand that. If you don't understand that, this is an opportunity to understand it. Okay, good. Now I'm going to draw only one wavelength, or what do you call it, one cycle. I'm going to draw 2 cycle. I'm going to draw 2 cycle. I'm going to draw 4 cycle. 1, 2, 3, 4. Understand that I take a rope, I move it up and down, I move it up and down, right? And spending 1 second, another person create 2 cycles. Other person take the same rope, moving up and down, create 4 cycle, spending 1 second. So different people can do things differently, as you see that. Okay, now what we're going to do, we're going to discover a few things. So you're going to write the time over here. Everything is 1 second, right? This one is 1 second, spend 1 second, 1 second, and 1 second. All right. So what we want to find, we want to find the first. We're going to want to find the period. Period is, of course, time over cycle. So the time is 1 second, and cycle is only 1 cycle. So period is 1 second. The period is the time 1 second. The cycle is 2. So period is 0.5, right? Second. The period is over here. The time is 1 second. The cycle is 4. So period is 0.25 second. Now let's draw the frequency, right? Frequency is simply 1 over period, right? So 1 over period. So 1 over 1 is 1 hertz. Frequency is 1 over period. So 1 over 5, 1 over 0.5 is equal to 2 hertz. And frequency is 1 over 0.25 is equal to 4 hertz, right? Good. Now we're going to write the equation. How can we write the equation? Which is simple. Equation would be for this one, y of t is equal to amplitude is 1 when there is no amplitude given, amplitude is 1, sine 2 pi over what? 2 pi over this, 2 pi over period, 2 pi over 1, and then t. So y of t, I'm going to write it for this one, y of t is equal to amplitude sine 2 pi over period. What is the period for this one? Period is 0.5. Don't forget t. The last one, y of t is equal to, the amplitude is 1, you don't have to write 1, sine 2 pi, what is the period? Period is 0.25. Don't forget t. Okay? Good. You can find other way. You can take this one, omega t, right? So in omega t, you have omega. What is omega? Omega is 2 pi over t, right? In this case, what is omega? Because we're going to do study wave number 3. So this is wave number 3. What is omega? Omega is, let's see, this is the omega, right? So omega is 2 pi over 0.25 or 8 pi. So omega is 8 pi. 8 pi 2 pi over t, right? Okay, good. So you can cross multiply, right? This is then t is equal to 2 pi over 8 pi, right? So pi cancel. So t is equal to 0.25. Many way you can do the same thing. This is one of the way. Make sure you feel 100% confidence when you do these kind of things. Okay, now let's go to let's use wave number 3 to do our thing, and that is discover those things. Let's make sure I don't erase it. Okay, this is wave number 3, and this is what we're going to discover. Okay, good. So this is what we're going to discover. Move them. Okay, good. I move them. All right. Wave number 3 we're going to use. For wave number 3, I just want to remind you, normal is move normal over here. So this is good, better. Okay, wave number 3. So we're going to analyze wave number 3. Wave number 3 frequency is 4 hertz, and period is 0.25 second. Don't forget that. Good. So first find the velocity. We have the air. Okay, we have the air. So this is the air. So let's move it over here. The normal, incident, okay, and then refracted. Okay, good. First we're going to find the velocity. This is what we're going to find, velocity. So, velocity over here is velocity equation is n c over v, right. So, then velocity in the air, right, is equal to c over n. C is 3 times 10 raised to 8, n is 1. So, the velocity of the light in the vacuum or in the air is 3 times 10 raised to 8. Now, let us find the velocity over here. Velocity of the water is c over n. Velocity of the water is c is 3 times 10 raised to 8 and n is 1.33. So, velocity of the light in the water is 2.25 times 10 raised to 8. So, 2.25 times 10 raised to 8. As you see, I am going to move them over here. I am going to move them over here somewhere. I don't need them, so I am going to erase them. Okay, I am going to move them over here. Okay, so let's move them over here. Okay, all right. This omega, I don't need omega over here. Okay, good. So, now we are going to update it and we see that velocity is not equal to, velocity 1 is not equal to velocity 2. Okay, check. Our hypothesis was, we fixed the hypothesis, our hypothesis of velocity 1 is equal to velocity 2 and that is not correct. Velocity 1 is faster than velocity 2. Good. Now, next we are going to see lambda 1 is equal to lambda 2. So, this is lambda 1, this is lambda 2, right. Okay, this is air, this is water. All right. So, how can we find the lambda? So, velocity is lambda 1 is actually velocity 1 over frequency 1, right. So, lambda 1 is velocity 1 is how much? 3 times 10 raised to 8 and frequency is 4, right. We are using this one 1, 2, 3, 4 yt. Frequency is 4 Hz and period is 0.25 second. Don't get confused between these two. Frequency is 4. So, lambda 1 is 7.5, I don't know. Let us see. 3 divided by 4 is 7.5 times 10 raised to 7 meter. Okay. So, lambda 1 is 7.5 times 10 raised to 7 meter. Now, let us find the lambda 2. This is lambda 2. So, lambda 2 is velocity 2 over frequency. So, lambda 2 frequency never changed. This is our hypothesis. So, that is why we are using the same frequency. We are using the same wave. Okay. So, velocity 2 is how much? Velocity 2 is 2.25 times 10 raised to 8 divided by 4 and that gives you 5.64 times 10 raised to 7, I believe. Let me see. 2.25 times 10 raised to 8 divided by 4, that gives you 5.6 times 1, 2, 3, 4, 5, 6, 7. Yeah. So, let us update it. Lambda 2 is 5.6 times 10 raised to 7. Okay, good. And then we see that lambda 1 is not equal to lambda 2 and that is check. Now, we are going to find frequency, right. Let us find frequency. So, frequency 1 is equal to what? How can we find frequency? Frequency 1 is equal to velocity 1 over lambda 1, right. Okay. So, frequency 1 is velocity 1 3 times 10 raised to 8. Why? Because we are doing air. And the lambda 1 is 7.5 times 10 raised to 7. And now we are going to frequency, we are going to do it for here. Frequency 2, I am sorry, we are going to do it for the water. Frequency 2 is velocity 2 over lambda 2. For the water, velocity is 2.25 times 10 raised to 8 and lambda 5.6 times 10 raised to 7. And what is magic is that this one is 4 and this one also 4. Don't forget to write Hz, don't forget to write Hz. So, you are going to come over here, we are going to update this, we are going to write 4, this one is 4 Hz and this one also 4 hours, right? Good. I don't need the equal sign over here. Okay, good. Now the next we're gonna do now, we're gonna move to the next problem, right? Because these graph do not give you any information of amplitude, because this graph doesn't move from water to air or air to water for that matter. The other thing, this graph also doesn't give you any information about what do you call the lambda directly. You cannot measure lambda from here, we have to do other way. So now to understand the other concept, we're just going to go to big idea number 2, when light move from water or from air to water, how would it look like? So let's see, when light move from so let's call it water and let's call it air, right? So let's see, so light is moving now from water to air. So I don't know, let me do it again. So over here, come over here, I need more space. So water, come over here, I need more space. So okay, so from water to air, right? Let's say from air to water, air to water. Okay, so let's see, let's do cosine. 1, 2, 3. All right, that's enough. Okay, now is water. Okay, so now it's water. 1, 'So this is 1, so it loses some amplitude, so make sure you show that it loses some amplitude. Okay, okay, so let's draw the other one. 2 and one more, 3. Okay, good. So what do you notice? And this is, let's say, y versus x. Okay, good. A few things we have to do. We have to find the amplitude. So let's find the amplitude. Amplitude is, to find the amplitude, amplitude is equilibrium. So this is equilibrium. So from equilibrium to the crest, and this is called amplitude, or from equilibrium to the trough, this is called amplitude. Right? So 0.01 meter, 0.0095 meter, 0.016 meter. Okay, and this one also I'm going to give you distance 0083, right? Okay, now you also can find crest to crest, and crest to crest also give you 0.016 meter, because on the handout I draw it to the scale, and then crest to crest also give you 0.0083 meter. Okay, good. Now we're going to write the equation. So let's write the equation. Y is equal to, this is cosine, but make sure you write the amplitude first, 0.01, and then you're going to write cosine, and then 2 pi, and then you're going to write the wavelength. What is the wavelength? Wavelength is 0.016 x. All right, now let's come over here. Y of x is equal to, let's first find the amplitude, 0.0095, 2 pi over wavelength, 0.008 x. Okay, that's pretty much it. So now we're going to do the axis slip, and axis slip is pretty easy. This is air, this is water, this is crown glass, and this is what do you call it, air again. You have a normal line, and you have the light striking the boundary with 30-degree angle, 30-degree incident angle, and it refract. We're going to find the refracted one. Okay, so what is this one? We're going to find that. Let's see. Before we find that, let's create all of them. This one will be smaller than this one because this n is bigger. The n is 1.52, n is 1.33, n is 1. Okay, so the light will even bend more. Okay, so now, what is interesting is this is not good. Light's going to be back to the 30-degree over here, and that's what we're going to prove, because this is 1 and this is 1. So they must have the 30-degree for both. Okay, so our goal is to find this one. Okay, so this is n1 sine theta 1 is equal to n2, this is n2 sine theta 2. n1 is 1 sine theta 30 is equal to n2 is 1.33 sine theta r. That's what we are trying to find. So theta r is equal to sine inverse sine 30 is 0.5, 1.33. So this is 22.1 degree. Okay. So the light is entering over here with 22.1 degree, and this one must be smaller, right? Why? Because this index is bigger than this one, right? n1, n2, n3, and n4. So n1 is equal to n4. n2 is smaller than n3. Okay. All right, so this one has to be smaller than 21.1. How much is smaller? We'll find out. So n2 sine theta 2 is equal to n3 sine theta 3. n2 is 1.33, sine theta 2 is 22.1, n3 is 1.52. We want to find this one, Q3, theta 3. All right, so this one is equal to sine inverse. You have 1.33, so 19.2. So this is 19.2. And now our hypothesis is that this one is 30, and let's see if that's the case. So this is n3 sine theta 3 is equal to n4 sine theta 4. n3 is 1.52, sine theta 3 is 19.2, n4 is 1 sine theta 4. So theta 4 is equal to sine inverse 1.52 sine 19.2, right? So theta 4 is equal to 30 degree. Now that we proved. All right. So this was practice test number 3 for the test you're going to take on Friday. So make sure you understand everything. If you don't understand anything, you ask me tomorrow.